Hello and welcome to the ALFRIED project. Today we are here in the RITS in Friedrichshafen, and my name is Julia and I want to present you some insights into this project. So first of all, I want to give you an explanation what IHSE is doing. So we are developing and producing products for the extension, switching and conversion of signals, and the term KVM stands for keyboard video mouse, and our products process these signals. Of course there are also other signals, but these are the main ones. In the easiest use case, you can use the KVM technology to increase the distance between the computer and the peripheral devices like monitors, keyboards and mouse. And due to the distance, you can place the computers in a secure room. This is essential for the cybersecurity concept because you can prevent the sensitive hardware from unauthorized access. Another aspect of the KVM technology is that only necessary signals are transmitted. For example, we have installations where USB 2 signals are not transmitted in order to minimize the risk of malicious hardware being smuggled in via a USB stick. An additional advantage of the KVM technology is that you have an efficient workflow for the operator in the control center, for example. We have no heat and noise caused by the computers because they are placed in a secure room, and also that then we can guarantee a clean and structured desk with only one mouse and one keyboard for an efficient workflow. For IHSE, the ALFRIED project is a great opportunity to create and implement ideas and visions for future control center, especially for the next generation mobility. And with our Smart City Control Center here, we want to make a contribution for a sustainable mobility system for the region of Friedrichshafen. For the implementation and realization of automated and connected driving, we have to collect a lot of data. The data came from the infrastructure and from the vehicle, and also metadata. And in the Smart City Control Center, we collect all this data and visualize them and present them to the operator. And the operator has the task to monitor and to control the traffic. And also, if an autonomous vehicle is struggling with a situation, the operator should be able to intervene and help the vehicle to solve the problem. IHSE has two work packages at ALFRIED. The first one is that we develop a concept for a Smart City Control Center, and together with the other project partners we implement this concept here in the Demonstration and Innovation Lab at the RITS. And the second part is to collect all data available at the test field Friedrichshafen and also of the city of Friedrichshafen. And in general, ALFRIED is focusing on the use case of inner city logistics. So the majority of our data came from the smart infrastructure and from the trucks. And on basis of this data, we can make recommendations for drivers and for road users for an optimal route planning. And while collecting all this data, we want to create the mobility data space for this region here. For the next generation mobility, we need a Smart City Control Center to collect, identify and analyze all data. And on the one hand, we are collecting data from the past to recreate situations and processes, and also to make statistics for the future. And on the other hand, we are collecting data from the current traffic. And by bundling this data, the technical operator in the Smart City Control Center can take the task of monitoring and control the traffic, and also in emergency case the controller can intervene in an autonomous vehicle if necessary.